On question 21, we are using our properties of logarithms to condense the logarithm. So the first thing I look for are numbers in front of the log, because if they're numbers in front of the log, we can put them back as powers. So 6 times the log of x will become the log of x to the 6th power. Leave the minus sign where it is, only take the 2. 2 times the log of y becomes the log of y squared. Now we're going to move from left to right. If 2 logarithms are added, we'll put them back together as a product. So I multiplied 12 times x to the 6th here. And then when 2 logarithms are subtracted, like they are here, we put them back together as a fraction. That subtraction bar looks like a fraction bar symbol, so that always helps me remember. And the 12x to the 6 goes on the top since it came first. Y squared goes on the bottom. Also notice that you have one single logarithm out in front. You do not show a log on top and a log on bottom. It's just a single log out in front. All right, on the next one, again, we will start with our properties of logs. If you've got more than one log on a side, you're going to want them together in order to solve. So since those were subtracted, I did make a quotient out of them. X plus 1 went on the top, x minus 2 on the bottom. And then, because I don't have logs on both sides, at this point I have to change to exponential form. So always start at your base. 3 is my base. I raise it to the power of 3, and then I say it's equal to whatever is sitting there. So that led me to this step, to which I then said 3 cubed is 27. And then I wanted to get rid of this fraction. So the way we get rid of a fraction is we multiply both sides by whatever's in the bottom. And so that canceled it there. That left me with 27 times the x minus 2, which I then brought down as 27x minus 54. Since I have more than one term with x's, I need them together. So I subtracted x on both sides. That left me with 26x. And then I added 54 to both sides to get the numbers on the other side. So 1 plus 54 gave me 55. And then when I divided both sides by 26, I was left with 55 over 26. Now, with log equations, you do have to make sure you at least visually check to make sure your answer does not cause you to take the log of a negative number. And you can, look at it in terms of a decimal if you want. 55 divided by 26 is a little bit bigger than 2, so it'll be okay because when you subtract 2, it'll still be positive. But if you ever had a case where plugging it back in creates a negative, like we'll see in just a minute, you have to throw that particular solution out. Now, the difference in question 23, you'll notice, is that there are logs on all terms. And so still, I'm going to say you start by using your properties to get a single log on each side in this case. Since those logs were added, we put them back together as a product, so you do have to FOIL here. And then, because of the fact that there are logs on both sides, you can actually just say their expressions must be equal. And that's what I've done on this step. So I did FOIL it as I went. So that's where I got my x squared minus 5x plus 2x minus 10. And then that was equal to x minus 4. So remember, back up here, we couldn't do it because we didn't have logs on both sides. We had to go to exponential form. But when we have logs on both sides, like we do right here, then that's when you can set their expressions equal like I've done. From there, since it's a quadratic equation because of that squared term, we do have to go ahead and set it equal to 0. So I subtracted x on both sides, I added the 4, and that left me with x squared minus 4x minus 6. Unfortunately, that does not factor, so I did have to do the quadratic formula again. So my b in this case was the negative 4, so I took the opposite of negative 4, plus or minus negative 4 squared, minus 4 times my a is 1, my c is negative 6, divided by 2 times my a. And then from there, I'm simplifying. So you end up getting a 14 or a 16 plus 24, which becomes a 40. If I break down 40 as 4 times 10, I know the square root of 4 will give me a 2 outside. And then I noticed that 4, 2, and 2 are all divisible by 2, so I can go ahead and reduce those. You can't touch the 10 because it's under the square root, but you can reduce those coefficients. So I actually ended up with two answers, 2 plus the square root of 10 and 2 minus the square root of 10. They asked me for my answer to have 4 decimal places, so when I did 2 plus the square root of 10, I got this answer, 5.1623, and notice when you look back, it's okay in all 3 places, so it does not create the log of a negative number. The problem is when I do 2 minus the square root of 10, I get a decimal that's negative 1 point something, and I just stopped right there because you'll notice if the decimal's negative 1 point something and you plug it in right here and you subtract 5, you're being asked to take the log of a negative, and we can't do that. So I actually threw out that particular answer because it's not valid. Finally, on question 24, we're solving an exponential equation. They do not have a common base in this case, so what I did is I wrote it in log form. 7 is my base. The power of negative x plus 5 goes over here by itself, and then the 636, that's what I'm taking the log of. So I still kind of make my circle like this, it's just I'm writing it in log form. In order to get x by itself, I had to first subtract 5 on both sides. Notice you can't go 636 minus 5 is 631 because this is tied together, so I had to leave it tied together there. And then finally, I divided both sides by negative 1. So from here, I got on my calculator and just punched it out, making sure you're dividing by negative 1 in the end. So my final answer there was 1.68.